So good morning everyone. Today we are going to conduct a class based on current electricity. That's chapter number 2 of higher secondary physics. So the exams are nearing for physics public examination for CBSE, ICSE and state syllabus. For students this class will be helpful for them. So we are starting with current electricity. So what is mean by current electricity? So current electricity is a branch of physics which deals with the flow of charges, or you can call that is dynamic state of charges. When a current carrying conductor, we are connecting a conductor wire with a battery, the electron star starts moving from one place to another place. So one side of the conductor wire to another side of the conductor wire, the electron starts flowing with respect to the magnet. Electric field creates there with respect to the electric field. So when a current carrying conductor is connected to a battery, there will be electric field produces. Due to that electric field, the electron starts moving from one place to another place. So that negative charge electrons are moving from one part to another part, and along with that the flow of current also moves. So when these charges pass from one part to another part, the direction of these charges are opposite to the direction of electric field. Now current electricity. So the current produced in the conducting wire, I is equal to Q divided by T. You can see the equation. Current produced in the conducting wire, I, the current I is equal to Q divided by T. Q is the charge which is flowed in the conducting wire with respect to a particular time. So that is I is equal to Q divided by T. The normal SI system, the electric current unit is amperes. And here which unit we are using based on this equation Q by T, the charge, unit of charge is coulombs and unit of time is seconds. So you can take coulomb per second also as the unit of current. So there are two units of current, ampere or milliampere you can take. Then based on this equation, I is equal to Q by T, unit of current is coulomb per seconds. Now we are going with an important topic from current electricity, the relationship between drift velocity and electric current. The relationship between drift velocity and electric current. What is meant by drift velocity? When the electrons, the negative charge electrons are passing through a conducting wire, it produces charges, right? So when it is moving, it is drifting from one place to another place inside the conducting wire. So it is drifting from one place to another place. The amount of velocity required to drift one electron from one place to another place is called drift velocity. So I can denote this drift velocity is V suffix d. I can denote this as V suffix d. So now I am taking the charge, amount of charge produced here. Before that, when we consider the area of the conducting wire is capital A, area of the conducting wire is capital A, and small n is the number of electrons passing through unit volume. Small n is the number of electrons passing through unit volume. Then NAVD is the electron flow per second. NAVD is the electron flow per second. So NAVD. So when we are taking the equation of quantization of charge, that is Q is equal to NE, N, small letter n, that is the number of electrons passing per second, that we got it as NAVD. So NAVD into charge, Q is equal to small n into E. Okay, then Q is equal to NAVD into E. Okay, then we are connecting with T. So that becomes NaVd into T you will get. Then we are considering this charge with respect to equation current. So I is equal to Q by T. Once again I will say quantization of charge Q is equal to N. So the quantization of charge Q is equal to N into E, small letter n into small e. The small e is charge of an electron, that is equal to 1.6 into 10 raised to minus 19 coulombs. So charge equation Q is equal to Ne. So the N is nothing but the total number of electrons passing per second, that we got it with respect to area and drift velocity, NaVd. So NaVd into E will give the total charge developed in the conducting wire. So Q is equal to NaVd into E. Then we are taking with respect to time. So with respect to time, it will become NaVdE into T. So we are considering the current I is equal to Q by T. So I is equal to NaVdE into T divided by T. So T and T will get cancelled. The current will be equal to NaEVd. So the electric current I produced is equal to number of electrons passing with respect to area A and the charge of electron E and the drift velocity Vd. So the relation between the drift velocity and electric current is equal to I is equal to NaEVd. I hope all of you understood this. So thank you.